Alright, this video is going to be all about inscribed angles, and the next video will be about inscribed polygons. So this word inscribed means inside of a circle. So an inscribed angle, you can see this image, means that all 3 points of that angle lie on the circle. The central angle, that hits that center. Inscribed goes from R to Q to P. So an inscribed angle, that's what we talked about. The arc that lies between two lines, rays, or segments is called this intercepted arc. So for example, this arc RP is the intercepted arc to angle ROP and to angle RQP. Okay, so the key idea here, I'm going to show you on Desmos first. Sweet. Okay, so take a look at this. We have an inscribed angle CBD and a central angle CAD. So this is interactive. You have this link. You can move this around. If you did some math here, you might notice that this angle, the central angle, is always twice as big as this inscribed angle. And that's the key idea here. This is this theorem, is that this CAD is twice as big as this angle CBD. The central angle is twice as big as the inscribed angle, when they have the same endpoints here. So that goes the same with this arc. So for example, if this central angle is 94, that means this arc, CD, is also 94 degrees, which means that this inscribed angle is also half the measurement of this arc. So that's a key idea there. So we'll go back to these notes. And we'll take a look at this. So this is this theorem, that's what we just talked about. It's called the Star Trek theorem because this symbol here looks like the Star Trek symbol. If you don't know, look it up if you're a Star Trek fan. There you go. Okay, so this just means the measure of the inscribed angle is 1/2 the measure of its intercepted arc, which is also the measure of that central angle. So let's do an example. Find the measure of angle T. So we're looking for this guy here. This angle T here. Notice that this angle RTS is an inscribed angle, which means that angle T equals half of that intercepted arc, 48 degrees, which means angle T is equal to 24 degrees. Measure of, this should be an arc QR. So find the measure of arc QR. I'm going to go ahead and erase what I have written down here. Okay, so I'm going to put this in blue, what we're looking for, and then I'm going to switch colors. Okay, so we're looking for QR, but notice we don't have an angle that connects to Q or R, but we do have this angle here, QRT. Angle QRT is 50 degrees, which means this arc, QT, is twice of 50, which is 100 degrees. Okay. Now, notice that this point P is the center, which means TR is a diameter, which means this arc, TQR, is a semicircle, which means this whole thing, TQR, is 180 degrees. And since TQ is 100, that means QR is 180 minus 100, which is 80 degrees. So that means measure of angle QR equals 80 degrees. Next up, we're going to find the measure of an intercepted arc. Kind of the same idea. So first, let's find the measure of arc RS. So we're looking for this arc here. Whoops. RS. All right, take a look at angle SUR. Angle measure 31. By our Star Trek theorem, this arc SR is twice 31, 2 times 31, which is 62 degrees. So, the measure of arc RS equals 62 degrees. Right on. Now we're going to use that to find the measure of angle STR. Okay. I'm going to switch colors. So we're looking for STR, we're looking for this angle. By the Star Trek theorem, this angle is half of its intercepted arc. So measure of angle STR is 1/2 of 62, that intercepted arc. Wait a minute. But that's 31. That's the same as that other angle. Take a look at these two angles, this angle T and this angle U, if you will. They both intersect that same arc. Therefore, they're the same measure. They're the same. So they're the same because they intercept the same arc. I'm going to write BC for because. They intercept the same arc. Okay, and that's the key there, which leads us into this next theorem, which will be the last thing I talk about in this video, which is the inscribed angles of a circle theorem. So if two inscribed angles of a circle intercept the same arc, then those angles are congruent, just like what you just saw. So that's it for this video. Watch the next one to learn more about inscribed polygons, which are polygons inside of a circle with every vertex on a circle. So email me with any questions.